Namaste, my friend, and welcome back to JEE Mathematics with Typical Monk. This is class 5, and today we count. Not counting like a child counts sheep, counting the G way, where a single word changes the entire answer. How many ways? How many arrangements? How many ways to choose? Every one of those questions hides inside it one of two ideas. The permutation, where order matters, and the combination, where it does not. When Sarah first met this chapter, she kept mixing the two and lost marks she already knew how to earn. We are not going to let that happen to you. Today, one idea at a time, we build the counting machine, the fundamental principle, the factorial, the arrangement, and the selection. Take a slow breath. Let us begin. So what will you carry home from today's class? First, the fundamental counting principle and the factorial, the base every counting formula stands on. Second, permutations, NPR, arrangements, including the tricky ones with repetition and restriction. Third, circular permutations and combinations, NCR, selections, where order plays no part at all. Fourth, dividing objects into groups and distributing identical or distinct objects. And fifth, the G drills, a word problem, a match, and a short answer round. So today's ideas become today's marks. Ready? One idea at a time. Let us start with the raw material, the building blocks every formula is made of. First, the factorial. N factorial means n times n minus 1 times n minus 2 all the way down to 1. It is the number of ways to line up n distinct things in a row. David once asked why we even need a symbol for it, because 5 factorial written out is 5 times, 4 times, 3 times 2 times 1. And G will not wait for you to write all that. Second, the permutation, an arrangement where order matters. A, B, C, and B, A, C count as two different outcomes, even though the letters are the same. Third, the combination, a selection where order does not matter. Choosing A, B, and C as a group is just one outcome, however you say their names. And fourth, a small but favorite G fact, 0 factorial equals 1 by definition. There is exactly one way to arrange nothing at all, an empty row, arranged in exactly one way. Now look at this tree, because it turns the fundamental counting principle into a picture. Start at the top, you are choosing a shirt, then a tie. First, the multiplication principle. If one step can happen in m ways, and a second independent step can happen in n ways, then both steps together happen in m times n ways. 3 shirts, 2 ties, 6 outfits. Second, the addition principle. If a step can happen this way or that way, and the two ways cannot happen together, then the total ways is simply m plus n. Third, look at the tree itself. Every branch is a choice, and every leaf at the bottom is one complete outcome. Count the leaves, and you have counted every possibility. And fourth, the real power of this principle. Even a frightening counting problem breaks down into small steps, and you multiply or add your way through it, one step at a time. Lisa calls it the single most useful idea in the whole chapter. Now we put numbers on, arranging and selecting. First, NPR, the number of permutations of n things taken at a time, equals n factorial divided by n minus r factorial. Second, NCR, the number of combinations of n things taken at a time, equals n factorial divided by r factorial times n minus r factorial. Third, a beautiful bridge between the two, since every combination of r items can itself be arranged in r factorial ways, NPR equals NCR times r factorial. And fourth, circular permutations, arranging n distinct objects around a circle gives n minus 1 factorial, not n factorial, because fixing one object removes all the repeated rotations. John should treat this list as one family of formulas, not 4 separate ones to memorize. Time to solve a full problem together. Slowly, the monk's way. How many 4-digit numbers using the digits 1 to 9 without repetition are even? Step 1. Write down what is given. We need 4-digit numbers, digits from 1 to 9, no digit repeats, and the final number must be even. Step 2. The even rule. A number is even only because of its last digit. So the last digit must be 2, 4, 6 or 8. That is 4 choices for the last place. Step 3. The remaining places. Once the last digit is fixed, 8 digits remain for the first 3 places. Filled in order, 8, then 7, then 6 choices. Step 4. Multiply by the fundamental counting principle. Total equals 4 for the last digit times 8 times 7 times 6 for the remaining 3 places. Step 5. The answer, 4 times 336 equals 1344 even numbers. Notice the path. Given the special condition first, the remaining places next, then multiply. Fix the restriction before you count the rest. That one habit solves most JEE arrangement problems. Now, the heart of the chapter, telling a permutation from a combination on site. Look at these 2 panels. First, the permutation panel. A, B, C in that order is one outcome. B, A, C is a completely different outcome. Even with the same 3 letters, order matters every single time. Second, the combination panel. Here, A, B, and C sit inside one circle. Every order you could say them in collapses into the same single group. Order does not matter here at all. Third, the bridge again, worth repeating until it is automatic. NPR equals NCR times R factorial, because each selection can be arranged in R factorial ways. And fourth, whenever a restriction shows up, a fixed seat, a band pair, a person who must be included, fix that special condition first into its own slot and only then count the ordinary remaining choices. Sarah's rule. Restriction first, arithmetic second. Now sit up straight. These 5 lines are what JEE actually asks, year after year. 1. NCR has a symmetry. NCR equals NCN minus R, and Pascal's identity. NCR plus NCR minus 1 equals N plus 1 CR. Both appear constantly. 2. Circular permutation of n distinct objects around a table is n minus 1 factorial, fix 1 seat, and only the remaining n minus 1 seats need arranging. 3. Never together or always together, problems fall to the gap method. Arrange everyone else first, then slot the special items into the gaps between them, or glue them into one block. 4. Repeated letters are a trap. Divide in factorial by the factorial of each repeated count, or you will count identical arrangements as if they were different. 5. At least odd at most, questions are usually faster by the complement. Find the total, subtract the cases you do not want, rather than listing every case you do want. Let us drill the JEE way. I read a claim, you decide true or false, and if it is false, find exactly where the reasoning breaks. First claim. The number of ways to arrange the letters of the word level is 5 factorial. Let us check. L appears twice and E appears twice, so swapping the 2 L's or the 2 E's produces no new word. We are overcounting. The true count is 5 factorial divided by 2 factorial times 2 factorial, which is 30, not 120. This is false. Repeated letters must always be divided out. Second claim. 6 people seated around a circular table can be arranged in 6 factorial ways. Think carefully. On a circle, rotating everyone by 1 seat gives the same arrangement relative to each other. So 6 factorial massively overcounts. The correct count is 6 minus 1 factorial, which is 120. This is false. Circular permutations use n minus 1 factorial, not n factorial. Third claim. NCR equals NC, n minus R. Check the idea. Choosing R items to include is exactly the same act as choosing the remaining n minus R items to leave out. This one is true. It is the symmetry property of combinations, and JEE uses it constantly to simplify. A quick match now. Say each answer aloud before I reveal it. NPR matches n factorial divided by n minus R factorial. NCR matches n factorial divided by r factorial times n minus r factorial. Circular arrangement of n distinct objects matches n minus 1 factorial. an arrangement of n objects with p alike of one kind and q alike of another, matches n factorial divided by p factorial times q factorial. If all four came to you before the reveal, the formulas are becoming yours. Here is a favorite G format. I read some statements. You silently count how many are correct. Statement 1. NCR equals NC, n minus R. Hold your verdict. Statement 2. The number of diagonals in a hexagon equals 6, 2. Think before you answer. Statement 3. NPR equals NCR times R factorial. So, how many are correct? Two statements, the first and the third. NCR truly has that symmetry, and NPR truly equals NCR times R factorial. But the second one falls. 6C2 only counts every pair of vertices, 15 of them, and that includes the 6 sides of the hexagon. Subtract those 6 sides, and only 9 diagonals remain. Two correct statements 1 and 3. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. Permutation and combination are basically the same thing, both just bigger items out of n. David believed this for weeks, right up to his first mock test. But here is the truth. A permutation counts arrangements, where order matters. A combination counts selections, where it does not. And the exact bridge between them is NPR equals NCR times R factorial. Myth 2. When letters repeat, like the two L's in level, you can still just use n factorial to count the arrangements. The truth, repeated letters must be divided out, or identical-looking arrangements get counted again and again. Divide n factorial by the factorial of each repeated letter's count, and only then do you have the true answer. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ideas you built today. Question 1. How many ways can 6 people be arranged in a row? 6 factorial, 720. Question 2. What is 7p3? 7 times 6 times 5, 210. Question 3. What is 6c2? 15. Question 4. How many circular arrangements of 5 people around a table? 5 minus 1 factorial, 24. And question 5. How many ways to arrange the letters of the word ball? 4 factorial divided by 2 factorial. For the repeated L12, if you cut off 5, you have truly understood today's class. Let us gather the whole class in one slow breath. The fundamental counting principle, multiply 4 and add 4 or, is the base every counting formula stands on. NPR equals n factorial over n minus r factorial for arrangements. NCR equals n factorial over r factorial times n minus r factorial for selections, and NPR equals NCR times r factorial links them. Circular permutations of n distinct objects equal n minus 1 factorial. Fixing one seat removes the repeated rotations. Repeated items must be divided out of n factorial and never together. Problems fall to the GAT method. NCR has a symmetry. NCR equals NC n minus r, and Pascal's identity connects consecutive rows of choices. And next class, we step into the binomial theorem, the expansion of a plus b, the whole raised to the power n, the general term, and the coefficients that count everything we learned today. Do not miss it. And so, my friend, we have built the counting machine. It may have looked like just factorials and formulas, but understand this, every time G asks how many, it is really asking whether you know the difference between arranging and selecting, and whether you can spot a restriction before you multiply. Sarah, David, Lisa, and John all started exactly where you are right now, mixing up NPR and NCR before it finally clicked. Be patient with yourself. Tonight, revise the difference between a permutation and a combination once, slowly. One idea at a time, you will crack G. Of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you in the binomial theorem.